Okay, welcome to my presentation for Math 661. My name is Katie Lagergren. For my presentation, I decided to try to look into some of the content that I've taught within my pre-calculus class, or I should say have previously taught over the last few years, probably since COVID. Took this lesson as you're starting to see it and decided to kind of throw it out. But with my pre-calculus students, we spend a significant amount of time with trigonomic functions and identities, and we have a lot more fun kind of towards the end of that material learning about different applications of trigonometry. And so looking at this content, and again, I basically for this presentation looked into a lesson I've already done and kind of tweaked it to it and added to it a little bit, and taking a look at how trig applies to complex numbers. So I'm going to kind of scan through this pretty quickly in terms of what you're seeing. I won't explain all of the problems, but I'll pause a little bit and would encourage you to pause the video so you can see some of the examples I've chosen to use for my students. And hopefully you can bear with my chicken scratchy handwriting as well. So for this lesson, I definitely, not super engaging, but asked students to read a little bit in their textbook to try to help kind of get an idea of what the complex plane looks like. And so then I tasked them with plotting this imaginary number, -3 plus 4, on the complex plane. We talk about distances and, the geometric representation of what we're seeing here, as we've talked about reference triangles within our trigonometry significantly. So that helps them make sense of what this R represents. And so then we talk about that modulus, or really that radius in the complex plane, and define it in terms of our right triangle we can see from that structure of the point. And then talk about the trigonometric form of the complex number, where it comes from, as you can see above, looking at the diagram and thinking about vectors, things like that. So again, define what the trig form of a complex number, some a plus bi, would be in terms of cosine and sine. And then give students some space to practice plotting points again, and then practice finding the trig forms, thinking about the argument of the complex number, as well as that modulus. What's fun to talk about this first question, you can see where my mouse is, just pointing out to students that trig forms of complex numbers are not unique because of those coterminal angles that start and stop at the same spot, but have different size of rotations. So that's just kind of cool to pose that question to students to help them think about why that might be true. So again, just a couple of examples. So the two complex numbers above here give students a chance to switch them from complex form to that trig form. I should say it's still complex, but in the trig form. And then we have a little fun with the arithmetic of complex numbers as well, so specifically product and quotient rules. A couple of examples, one where they're finding a product, and one where they're finding a quotient. So again, I would encourage you with some of these examples and the work that I've provided on screen, I would encourage you to pause the video and take a look at them. Try to write out the work as my students would want to see it if they were reading my work, as well as if I was teaching it on the board in the front of the classroom. And then I'd finish up talking about finding nth roots of complex numbers. So a few examples of that. It has been at least 5 years since I've taught this lesson. And I did this part. Some of the things I added to it was, more drawing in the complex plane and things like that, that I haven't previously done. But I have done this part with students, and it was always so abstract for the students. So I thought for a little while of how I could tweak this to make it a little bit better. But to be honest with you, I think it's always going to be abstract for the students that I'm targeting because of their experience with the content. Like this would be some of the first times where they're really diving into some of this stuff. And so it'd be fun to see where it could take them, what questions they might have, especially the why do we want to do this part. So I don't think I'm quite 100% answering the question or the task of applications of complex analysis. But I thought this was the best way for me to kind of practice a little bit in terms of how I might use this in my classroom with my high school students this next school year. And like I said, this part specifically I've done in the past, so I look forward to trying to get back to that again this year. But a couple examples. So the first one, finding the third root of a complex number in trig form. And then cube roots of -I as well. So that is my application of some of the content I've learned throughout this course, and how I might use this in my classroom. So thanks for watching.